Hey folks, today we're going to learn about designing an experiment as a scientist, and our system that we're going to be exploring is one of these. A paper helicopter. As you can see here, the paper helicopter is just a piece of paper cut out into a Y shape. You can see it started like this and got bent like that, and we've got a paper clip on the bottom to weigh that part down, and when you drop it, the paper helicopter spins in a really slow, beautiful sort of way as it descends to the ground. Now I know you're probably thinking, we haven't talked about helicopters or flying or anything like that in lecture at all. I don't know how this works. That's great, because when we're designing scientific experiments, we don't know the answers. And that's what you're working on in lab this week. You're looking at all the different variables that might go into constructing one of these helicopters differently to see if you get a different result. So we're going to leave it up to you to ask a scientific question and then design an experiment in order to answer that question. We need to make sure that we have something to measure that we can compare from one paper helicopter to the next. That thing that we're going to measure is going to be flight time. We need to keep our variables constant, and so one of the things that means is we're going to have to make sure we're always dropping it from the same height. Obviously, if you drop it from higher up, it's probably going to take longer to hit the ground, right? So we always want to be dropping it from the same height. And when I drop it, let's see if I can find, I want to use centimeters here. Here, 180 centimeters. That seems like a good place to drop it from. And notice, when I drop the paper copter, I'm not throwing it up in the air, I'm not throwing it down or to the side, I'm just letting go. That's also going to be really important. Just let go, don't throw it, because you can't repeat the way that you throw the paper copter each time, right? You don't have good control over that. And so we're just going to drop it, and that's something we can do reproducibly. As scientists exploring this system, you're going to be working with all the different variables that can go into designing a paper helicopter and seeing whether or not they affect the flight time of the helicopter and by how much. Some variables might include the overall size from top to bottom, or maybe just the size of the propellers, which are from here to here, or maybe the width. You can make it narrower, longer, wider, however you want to do it, and we can be precise about this by measuring all of those dimensions. And we can change the weight on the bottom. We also have different types of paper that you'll be able to experiment with. So you don't want to change all of these variables, but if you want to design a well-controlled experiment, you can change one thing at a time, and you get to define what that change is and make a prediction and see how it affects the flight time. The actual physics of what are happening with this paper helicopter, even though it's very simple, are actually pretty complicated. And so we're not going to be able to figure out an equation that will make predictions. This is actually pretty complex, because as you've seen, as this paper helicopter falls, it has to start twirling around, and as it twirls around, it gets an even distribution of drag and a big circle around here. But how is it going to get into a stable twirling motion? How much drag is it going to get in order to slow its descent? It ends up being a difficult thing to calculate and not something we're going to be doing here. You're just experimenting with, I'm going to try making this change, and I want to see how that change affects the flight time. All right, so have fun designing your experiments, and if you'll excuse me, I'm going to play with my paper helicopter. Yeah, go!